Hi, back for video number 2. Hopefully it's better than video number 1. I'm not sure what happened. But what I want you to do for video number 2 is I want you to get your mole honors problems, and I want you to look at problem number 12. Dimethylhydrazine. The fuel used in the Apollo has a molar mass made up of carbon, hydrogen, nitrogen. The combustion of 2.85 grams yields 4.190 carbon dioxide, 3.420 H2O. Find the empirical formula. It's made from C, H, and N. Now, this is the problem. I've got 2.859 grams of this. But I don't know how much, out of the 2.859 grams, how much is carbon, how much is hydrogen, how much is nitrogen. So the first step is to find the amounts of each of the elements. How do you go about doing that? I'm going to give you a clue. And the clue is write a combustion reaction, adding oxygen. And then from that combustion reaction, figure out the percent composition of the products. That will help you find the amount of carbon and hydrogen. So I want you to turn this off right now. I want you to try to solve that problem, and then turn it back on and I'll have the solution for you. Okay, go. All right, we're back. And let me do the solution. Like I said, they want you to find 2.859 grams of this fuel that's C, H, and N. And all we know is what it yields. It yields carbon dioxide and H2O, so that means I must have excess oxygen. It says it's excess oxygen. So I'm going to write the equation. I've got this fuel, CHN plus O2 is going to yield CO2 plus H2O. Now, the law of conservation of matter says that matter can't be created or destroyed. So all the carbon I have in the carbon dioxide has to come from the fuel. So if I can figure out how much carbon is in carbon dioxide, I can figure out how much carbon is in the fuel. If I can figure out how much hydrogen is in the water, I can figure out how much is in the fuel. How do I go about doing that? Percent composition. So I've got 4.190 grams of carbon dioxide. 4.190 grams. Percent composition. 12 grams of carbon in 44 total grams. Means I have 1.14 gram of carbon. All that carbon, the only place I can get carbon is right over here. So now I know I've got 1.14 gram of carbon. Next, hydrogen. Hydrogen, I've got 3.428 grams of water. How much hydrogen is that? Well, that's going to be 2 grams over 18 grams, which gives me 0.381 grams of hydrogen. 0.381 grams of hydrogen. Now, how much nitrogen do I have? Well, I know the total amount is 2.859 grams. So I've got 2.859 grams total minus the grams of carbon, which is 1.14 gram, plus the grams of hydrogen, which is 0.381 gram, which is equal to, got it written down here on the side, how many grams of nitrogen do I have? 1.33 grams. 1.338 grams of nitrogen. So now I've got the grams of nitrogen, grams of carbon, grams of hydrogen. Do you all see that? Step one is finding the number of grams. How do we do it? We write the equation. We know that all the carbon has to come from the carbon dioxide, all the hydrogen has to come. We don't care about the oxygen. Alrighty? Now I've got my amounts. So I'm going to take my amounts right here, and I'm going to say carbon. 1.14 gram of carbon, change it to moles. 1 mole is 12 grams. That gives me 0.95 moles carbon. 0.381 grams of hydrogen. 0.381 grams of hydrogen. 1 mole, 1.10 gram gives me 0.377 moles of hydrogen. And now I'm going to take, I got carbon, I got hydrogen, oxygen. What did I say oxygen was? I said it was, or nitrogen, I'm sorry, nitrogen. 1.338 grams of nitrogen. 1 mole, 14 grams equals 0.095 moles of nitrogen. Now, I do that. Oh, carbon and nitrogen are the same. Let's divide 0.377 moles of hydrogen by 0.095 moles, and that gives us 4. Which means I've got 4 moles hydrogen, 1 mole carbon, 1 mole, 4 moles, did I say 4 moles? 1 mole nitrogen. Perfect. So my empirical formula is going to be CH4N. CH4N, empirical formula. They want the molecular formula, and they say the molecular formula is 60 grams. 60 grams divided by the mass of the empirical formula, which is going to be 12, 26, 30, is equal to 2. So my molecular formula is equal to C2H8N2. Okay, now what I want you to do is I want you to look at problem number 11. 11 is difficult. I wouldn't expect you to be able to do 11. I want you to look at it and spend a couple of minutes and see what you can do, and then I'm just going to talk a little bit about it, how to go about doing it. It's more about understanding how to go about doing it than necessarily doing it. So, you do that. After you spend some time on it, I'm not sure you're going to be able to solve it. Come back and we'll go over it. But here I'm going to give you a minute to look at this. And remember, what we did was percent composition. Remember, I keep talking about whatever you learn now, you're going to have to use later. And this is what we did. Combustion reactions, percent composition. And then we found empirical formula. All right, so give it a whirl on that problem. And then I will come back and I will talk a little bit about that problem. Okay, you guys are back. You're back. I'm back. Let's look at this problem. This problem is a little bit different because this problem says B6 contains carbon, hydrogen, nitrogen, and oxygen. And when I have 10 grams of it, burning oxygen. So now I'm adding oxygen to it. So I'm going to have CHNO plus O2 because I'm burning it in excess oxygen. I've got 10 grams of it. I'm going to get carbon dioxide plus water. 19.88 grams of carbon dioxide, 19.88 grams, and 4.79 grams. 4.79 grams up here. And it says B6 made up 14% nitrogen, so my nitrogen is going to be 14%, which is 1.4 grams. Well, if I could find the number of grams of carbon and hydrogen, add it to 1.4, subtract that from 10, because it's all 10, that will give me my amount of oxygen. So, let's try this. 19.88 grams of carbon dioxide, 12 grams of carbon and 44 grams of carbon dioxide. Grams of carbon dioxide gives me, I've written it over there, I'm looking, 5.42 grams of carbon. 4.79 grams of H2O. Let's see, that's 2 grams for 18 grams. Excuse me, 2 grams for 18 grams. Gives me 0.532 grams of hydrogen. Now, how many grams of oxygen do I have? Let's take 5.42 grams plus 0.5322 grams plus 1.4 grams of nitrogen, and I end up with how many? 2.65. 2.65 grams of O2, of oxygen. Perfect. Perfect. Let's figure out how many moles that is. So now I'll go right over here. Let's figure out how many moles of carbon I have. 1 mole divided by 12 grams. It means I have 0.45. 0.4517 moles of carbon. Take the hydrogen, 1 mole over 1.01 gram gives me 0.527. 0.527 moles of hydrogen. Nitrogen's going to be, what do we say nitrogen? 1.4 gram. 1.4 grams of nitrogen. 1 mole over 14 grams gives me, of nitrogen, 0.1. So I got 0.100 moles of nitrogen. And then my oxygen up here, which is 2.65 grams. 1 mole over 16 grams gives me 16 grams. How many? Did I not figure that out? I didn't figure that out. All right, let me get my calculator here. Excuse me. And I get 2.65 divided by 16 equals 0.16. 0.1656 moles of oxygen. Well, as you can see, these numbers are way crazy. I'll put this right here. 0.1656 moles of oxygen. And if I was going to try to do this, I would keep pounding away and dividing by the lowest number, and I would end up with something that's something like I said, I don't expect you to do this. I think it's C17H20N4O6. Now, O and N, they're small, that makes sense. I wouldn't expect you to come up with that. You might come up with something, but It's just the whole idea of how to solve these problems, how to figure out how much grams you have, and then use the whole process of solving your empirical formula. That's really good. So, real quick, before I go, the quiz is going to start with solving problems, conversion factors, dimensional analysis, sig figs, scientific notation, the mole, empirical formula, molecular formula. Basically everything we've done since we started talking about conversions. And what do? Go over your old tests. Very important, go over your old tests. Go over all the problems we've done. And if you do that, you can do all those things. I think you'll be in great shape. If you got problems with something, look in your book, see if that helps. Try Khan Academy, see if that helps. Come visit me, see if that helps. If anything, you should be well prepared for this quiz on Tuesday. I hope you have a great day. I hope these videos helped.